Earth's oceans are full of animals that seem pretty strange to us landlubbers, but the most alien creatures are found down here, in the Southern Ocean. Hi, I'm Cameron, and this is Minute Earth. In the Southern Ocean, even the most normal-looking critters are secretly bizarre, like this Antarctic icefish. While other fish have red blood due to their oxygen-carrying red blood cells, Antarctic icefish have clear blood that lacks those cells. Icefish also have gigantic hearts compared to red-blooded fish. They have the ability to absorb oxygen directly through their smooth skin as opposed to just through their gills, and on top of that, they have a natural antifreeze in their body fluids. Despite the harsh temperatures, some of the planet's longest living animals live in the Southern Ocean. Starfish here tend to live 100 years or so. Compare that to the 3 to 5 years a tropical starfish might live, if it's lucky. Heck, there is an individual animal, a sponge, on the Southern Ocean seafloor that scientists guess could be as many as 15,000 years old, based on how big it is and how slowly it grows. It's a frontrunner for the planet's oldest living animal award. Also, in general, animals in the deep sea get huge, but animals in the depths of the Southern Ocean get even huger. Some of its giants include the Antarctic blue whale, the largest animal on the planet, and the colossal squid, the largest invertebrate on the planet. Seafloor dwellers too get relatively big. Antarctic sea spiders are the size of dinner plates, scale worms are the size of marine biology textbooks, and freaky 20-armed starfish reach the size of manhole covers. All of these animals that live in the Southern Ocean are weird because the Southern Ocean itself is weird. Although the Southern Ocean seems like it's connected to our planet's other oceans, its life is completely cut off from the rest of the world's oceans by what is essentially a giant circular river called the Antarctic Circumpolar Current. It is the largest and fastest ocean current on the planet, and it's also the deepest. It exists as a giant spiral of water that extends from the surface to the seafloor, acting as a barrier that has prevented most Southern Ocean life from interbreeding with life from other oceans for the last 30 million years. But there's a benefit to being trapped behind the current. As it spirals, it churns up nutrients from the depths, which means that the Southern Ocean is full of food for all of its strange life. Plus, the isolated water happens to have unique properties. It's very salty, allowing it to get super cold without totally freezing. And that cold water allows it to hold on to lots of dissolved oxygen, which might help animals to get bigger and age slower than they would elsewhere. Scientists are studying Antarctica's frigid, isolated oceans, and the weird critters that live there, to learn how life manages to thrive in such extreme, alien environments. Seriously, conditions in the Southern Ocean may be more similar to other worlds, like Saturn's biggest moon, than to the rest of our own. But even if aliens don't exist, the Southern Ocean is an otherworldly wonder right here on Earth. I squid you not. We made this video in partnership with some friends who actually get to do scientific work in the Southern Ocean. This year, Dr. Holly Bick and science communicator Dr. Virginia Schutte, who wrote this video, embarked on an ice-breaking research voyage in the Southern Ocean to better understand the strange life beneath the ice. Nematodes, little soil-dwelling worms found on and off of every continent on Earth, are Dr. Bick's specialty, and with the support of the National Science Foundation Office of Polar Programs, she was able to use the cruise to gather samples of nematode life from the Southern Ocean seafloor with the intention to not only describe new species, but also to find out what makes Antarctic nematodes tick, or keep ticking despite living in such an extreme alien place. Studying their genomes can help pinpoint adaptations to polar ecosystems and possibly teach us how organisms all over the world may demonstrate resilience to climate change.